All right, so let's finish up section 2.2. Okay, so last time we looked at a couple examples where we had to find the right window. Okay, keep in mind, sometimes your window, you got to really zoom out a lot. It can get pretty big, but it just takes a little practice to find the right window. All right, so we're going to start out with an example where a company has two different kinds of costs. They've got what's called fixed cost and variable costs. Okay, you don't have to write that. That's just what we're going to do. Okay, so this particular company has a fixed cost of $200,000. Okay, so a fixed cost might be like a salary. All right, they pay $200,000 in, say, salaries to all their employees. And this particular company is going to make T-shirts, and they have a variable cost of $1.50 per shirt. Okay, the reason this is variable is because it depends on how many shirts they make. If they don't make as many shirts, it doesn't cost them as much. If they make more shirts, it's going to cost them more to make more shirts. But the salaries they pay the employees stay the same, regardless of how many shirts they have made. Right, so the variable cost also includes a profit here. Okay, so they sell each shirt for $4. All right, so we could figure out what the profit is in that. If it costs them $1.50 to make it, they sell it for $4. We could figure out how much money they're making per T-shirt. Not what we need to do right now, though. So first thing I want to try to do is come up with an equation, okay, that represents their costs, okay, including the fixed cost and the variable cost. And then we'll come up with a separate equation that represents their revenue. Okay, revenue is just money that they take in. Right, so we know how much money they take in per shirt. So that's going to be part of the revenue. All right, anyone think they could give me an equation for the cost? The fixed cost and the variable cost. So we're going to have a letter in there somewhere. We're just going to make sure we put it with the right number. Yep.
200,000 plus 1.5x.
Sure. So X, I'm guessing you use that. That's the number of shirts they sell. Yep. So the cost is 1.5x. Okay, so they pay $1.5 for every shirt they make, plus the fixed cost of $200,000. That's it. There's your cost. Any question on that? So when we graph that, we're going to be thinking some pretty big numbers. It has a y-intercept up at 200,000. All right, so we're going to have to set it pretty high. Okay, and the revenue. Okay, we'll call that function R. What's the revenue here? That's just how much money they take in. $4. Yeah, they take in $4 per shirt. Now that's not necessarily the profit. Okay, that would have to take into account cost. But the revenue is just how much money they take in. Okay, $4 a shirt. That's it. That's all they wanted for that one. Okay, any questions on that? All right, so there's our equation for cost. There's our equation for revenue. Hang on to those for a second. We're going to come back and graph them as soon as I talk about the break-even point. Okay, anybody have an idea what that is? What the break-even point is, Kyle?
Like, if you spend, let's say, $10, the break-even point when you try to make money off it is $10 because you got back to where you started.
Yeah, it's basically you get right back to where you started.
Yeah.
It's when the amount of money you've spent to make something and the amount of money you've taken in are the same. It's where your cost and your revenue are equal. All right, so we're going to use that idea basically to figure something out in the last problem. Now, if you were to graph your cost and your revenue, and you want to know where they're the same, where would that point be when you draw the two lines? Yeah, it'd be where they cross. Okay, so graphically, you're looking for where two lines cross each other. where the lines cross. Okay, any question on that idea, break-even point? Okay, a break-even point is not something you have to do graphically. We could do it with algebra. In fact, why don't we, we'll do it both ways. We'll do it one way with algebra, and then we'll do it as a graph. All right, so let's go back and look at our two equations. Okay, cost and revenue, because we need those. All right, so how would I set up an equation to find the break-even point using C of x and R of x? What would I do with those two things? Multiply?
Right.
Nope. It's not like an add, subtract, multiply, or divide. It's a little different.
You want to set them equal to each other.
Yeah. Take your cost, set it equal to your revenue, and solve. All right, so my cost is that top equation, 1.5x plus 200,000, and set that equal to my revenue. In this equation, I'll have 2 steps to solve it. Okay, Brendan, what's my first step to solve that equation?
Move 1.5 over.
Yep, and how do you move that to the other side?
Divide it.
Careful, it's not multiplied by the 200,000.
Oh, okay.
Yeah, you're going to subtract it. Okay, so subtract that 1.5. 4 take away 1.5 leaves you with 2.5. And Jamie, what's my last step? Yep, now I'm going to divide by 2.5. Okay, let's see what that comes out to. Comes out to 8,000?
80.
80,000, okay, thank you. So X is 80,000. That's how many shirts they need to sell to break even. Okay. Once they sell more than 80,000 shirts, they're going to start making money. If they don't sell at least this many, then they're going to lose money. Okay. So that's how you do it algebraically. Any question on that? Okay, now let's graph. So basically what we'll do, put that in y1, and put that in y2. Right? And we're going to see where they cross. Now, we already know where they cross. So I have an idea of, bless you, how big I need to make x max. Okay? Maybe even go a little bit bigger. All right, let's type it in. X. And the other one, 4x. All right, in this problem, would negative t-shirts make sense? No. So let's not worry about selling negative t-shirts. Okay. X max, we already know how many we need to go up to, but it's always good to go a little beyond it. So let's just go 100,000. Okay, this one, well, we don't really need to look at negative cost. You're never going to have negative cost. And you're never going to have negative revenue. Those don't make sense. All right, so that's as low as we need to go. And now this one has a y-intercept of 200,000. Okay, y1. So we need to go at least to 200,000, or you won't even see the graph. So let's, I guess let's try 400,000. All right, and then just hit graph. And if we don't see it, we'll adjust our window. Actually, I think that's okay. Yep, that's good. All right, so we can see where they cross. I'm going to go second calc, intersect. Pick a point on the first curve, hit enter. Second curve, hit enter. And then the guess. Does the guess really matter in this case? No. All right, if you have maybe a parabola like a U shape, you'd have to put the guess closer to the intersection you want. But there's only one. So it gives us the same answer. X is 80,000 shirts. Okay, what's that Y? What's that 320,000?
That's money.
That's money. Okay, so if you sell 80,000 shirts, you're going to make $320,000. You're also going to spend $320,000. This is right where you break even. Okay? Okay, any questions on doing it algebraically or graphically? All right. I think that's it for that section. Okay, so that's 2-2. All right, so section 2-3, it's a review a little bit on solving linear equations. Okay, kind of like the one we just did in the last section. Okay, that was a linear equation. And then we'll talk a little bit about quadratic equations. All right, so first of all, what makes something an equation? Well, an equation has to have an equal sign in it. Basically, it's a quality between two expressions. So you got something on the left, something on the right, and an equal sign between them. Okay, that's exactly what we just did in the last section. We put cost on one side, put revenue on the other, put an equal sign between them. Okay, so we made an equation. Okay, if the equation uses x like we did in the last problem we set up, we can say that we have an equation in x. Okay? An equation in x just means you have an equation and you used x as the letter. Right, when we solve an equation, okay, solve basically means to find all values for the variable that make the equation true. Right, so in that last one we set up with the cost and revenue, we solved for x. X was 80,000. In that particular problem, there was only one answer. There's only one number of shirts that you could make to have your cost and your revenue be exactly the same. Some equations have more than one answer, but that one didn't. All right, so some equations have exactly one answer. Some equations have infinitely many answers. Okay, that's not like the one we just did. This one would be a little different. Okay, and if an equation is true for any number that you pick, you can pick any number you want for x. You can pick a positive, negative, decimal, fraction, and it always works. That's called an identity. That equation right there, that's an example of an identity. Okay, watch what would happen on the right-hand side if you went to solve it. Okay, first thing you do is distribute that out. So on the left, you'd have 3x plus 2. What's that? Yeah, they're going to be the same, right? On the right, you have 3x plus 3 minus 1, which is 3x plus 2. So now when you get something like this, you go to solve it, you have the same thing on the left and the right. You can pick any value for x and it'll make this true. You can pick 1, 2, negative 5, decimals. Any number will work. All right, so an identity is an equation that's true for all values of a variable. A conditional equation is true for certain values. Here's a conditional equation, 2x equals 10. That equation is true if you pick the right number for x. In this particular case, what value would make this equation true? 5, yeah. 5, and is there any other number? No. Okay. Sometimes conditional equations have multiple values that could make it true, like that one. What value would make that one true? 2. 2 times 2 is 4. And what else? Negative 2 times negative 2 is also 4. This is a conditional equation. It has 2 solutions. This is a conditional equation with 1 solution. And another type, I didn't put it up here, but you can have an equation that's impossible to solve. Okay, if I gave you something like 2x plus 3 equals 2 times x plus, let's see, 2. You're not going to be able to solve that equation. Because when you distribute it out, you get this. Subtract 2x from each side. You're left with 3 equals 2. Oh, thank you. Yes, 2x plus 4. Yep. Still, that's okay. So you still can't solve that. All right. You get 3 equals 4. All right. So no matter what number you try to pick for x here, there's no solution. The name for that, I guess it's a contradiction. 2x plus 3 can't equal 2x plus 4. It's not possible. If you want to check if a number is a solution to an equation, hey, you just plug it in and see if you get a true statement. All right, so all I want to do here is just verify that when you plug negative 2 in, it's a solution to the equation x cubed minus x plus 6 equals 0. All right, so when I fill negative 2 in on the left-hand side, and then I simplify the whole thing, what am I hoping to get on the left?
Equal to 0.
I'm hoping to get 0. If I get something other than 0, this is not a solution. Or I made a mistake. Okay, let's plug negative 2 in for x, see what we get. We get negative 2 cubed minus negative 2 plus 6. And I'm going to put a question mark over that equal sign because we don't know. That's what we're hoping. Okay, Pat, what's negative 2 cubed?
Negative 16.
No, not 16. I won't power too far.
Negative 8.
Yeah, negative 8. And Derek, what happens when you do minus minus 2?
Plus 2.
Plus 2 plus 6. Okay, negative 8 plus 2 is negative 6. And Tyler, is negative 6 plus 6 0?
Yeah.
Yeah, so we're good. All right, so negative 2 is a solution. We just verified it. Okay, any question on how to verify a number is a solution? Okay. So that's an example of a linear equation. It's kind of like the cost formula we had, 1.5x plus 200,000. So in a linear equation, a and b can be any real number that you want. A and b are real numbers. Except the only thing a can't be is 0. Because if you make a 0, you'd have 0 times something, which is always what? 0. So if you make a 0, you just wipe that right out. Now you have b equals 0. Okay, that's not a linear equation. Okay, so a and b, any number you want, except a can't be 0. Okay, so algebra 1 type of equation. Okay, not the kind of equation I would start off with in algebra 1 because it's got a lot of fancy things going on here, but hopefully everybody feels pretty comfortable solving that. Okay, Dalton, what would be my first step on the left-hand side?
Distribute.
Yep, and when I do that, can you tell me what I'm going to get?
Yeah. 4x minus 6 and 3x plus 3.
Yep. Okay, right-hand side, this just stays the same for now. Okay, Nick, what would I do next?
Add like terms.
Yeah, combine your like terms. So we've got some x's on the left-hand side, and we've also got some constants. Can you combine everything you can together for me?
7x plus 3.
What's negative 6 plus 3?
Oh,
Negative 3. All right, so we combined everything we could. Now we're going to start moving stuff from side to side. All right, Paige, what would I do next here? You have a couple choices you could do.
Add 3.
Sure, yeah, you could add 3 to both sides. And what's that going to give me on the right?
5.
Yep, it's going to give me 5. And now, if we put all the numbers without x's on the right, I'm going to put all the numbers with x's on the left. So subtract your 5x. And Tommy Lee, my last step,
Divide by 2.
divide by 2. So x equals 5 halves. Or you could put 2.5. Fraction's fine. Okay, that's really the only time I plan on kind of reviewing those Algebra 1 type equations. But any questions on that? All right. Okay, another type of equation you looked at in Algebra 1, it's called an absolute value equation. And basically the way we do this problem is we split it into 2 problems. If we need to, we'll get the absolute value by itself first, if we need to. And after we do that, we'll split it into 2 problems. Okay, the 2 equations we're going to get when we split it apart. Well, the first one is the same as the original problem, except all you do is take away the absolute value bars. Okay, so one of the 2 equations you're going to split it into. Same as the original problem, except without the absolute value bars. You just take them out. Okay, now we need our second equation. Okay, so the second equation starts out the same. It's the same as the original, except without the absolute value bars. That's just what you did for the first equation, except you got to do one more thing. There's going to be a number on the other side of the equal sign. You got to change the sign of it. Okay, so second equation, copy down the original, take away the bars, put the number on the other side, change the sign of it. Okay, that's what negate means. Change the sign. And there's an example of a absolute value equation. In example 3, is the absolute value already by itself on the left-hand side?
Oh,
Is there anything outside the absolute value bars on that left side? 5, that's on the right, so don't worry about the 5. But how about on the left, Kyle? No. Okay, there's nothing on that left-hand side outside the bars. So the absolute value is already by itself. Let me show you an example where it's not. Let's do something like this. Let's here's an example where the absolute value is not by itself. Okay, first thing I'd have to do in this problem is divide each side by 2. Okay, and what that would do, now it would make it 2x plus 3 in absolute values equals 5. Okay. Any question on that if you had to do something like that? Okay, in this problem, you don't need to. I already got it by itself for you. You'd do the same thing if there was a number on the outside like that. You'd subtract 1. Yep, you'd subtract 1, move it to the other side first. All right, so let's split this into 2 problems. Okay, first equation. Take the original problem and just erase the bars.
You don't do 2x plus 3 negative 5.
Yep, so that's going to be our second one when we do the negative 5 on the other side. Anybody give me my first equation, though? First one I'm going to solve. Whoopi?
How do you say in my mind?
Yeah, go ahead. What do you think it
2x
is?
plus 3 equals 5.
2x plus 3 equals 5. Good. Right, so that's our first equation. And my second equation. Jamie?
2x plus 3 equals -5.
That's it. That's how you do it every time. Separate it into 2. Take the bars out. On the other one, take the bars out. Make it negative. And now solve each equation. So we get 2x equals 2. Or x equals 1. Okay, and the other solution, minus 3. Get 2x equals negative 8. Or x equals negative 4. And that's it. That's an absolute value equation. Generally, absolute value equations have 2 answers. And if we were to graph that, okay, just watch me. You don't have to graph it yourself. But this might be handy if you don't remember where absolute value is. Math, number, absolute value. If I put what's on the left in y1, put the right in y2. Okay, at 2x plus 3, it's a V shape. Remember, absolute value can't go negative. That's why it kind of hits the x-axis and bounces off it. Because it tries to go negative, and it's like, nope, I'm going to go back up. And notice it's going to cross it in 2 spots. Well, those 2 spots are the 2 answers we just found. 1 and negative 4. Right. What other possibilities do you think there are? So this one had 2 solutions. What else do you think I could get?
5 I mean,
Besides 2 solutions. Think you could get 3 solutions? Think that V could ever cross 3 times? No? Matt, what else do you think could happen?
One solution?
Yeah, it could cross exactly once. Let's say I made that 0. Okay. Now what's going to happen is it's going to just cross 1 time. It's not even really going to cross. It's just going to kind of touch it and go back up. And what else could happen? 2 solutions, 1 solution. Yeah, you could have no solution. Okay, in this case, I'm asking you where the absolute value equals negative 3. Well, does absolute value ever equal a negative number? No. So in that case, that's no solution. Generally, you have the 2 solution case. All right, mixture problems. Okay, this will be our last type of linear equation, then we're going to finish up with quadratics. Okay, mixture problems generally require 2 equations. Okay, we've got to make 2. Okay, that's 1 equation. That's our second equation. Okay, let me kind of explain what those are. So when we do a mixture problem, usually they're going to give us two things we're going to mix together. A lot of times they do like a solution. They might say you're going to mix a 10% solution and a 20% solution. Okay, that's what you're going to mix. And when you're done, I want you to mix it together so you've got 20 gallons. And I want it to be a 13% solution. All right, so they'll tell you how much they want you to have. And then they'll tell you what they want the concentration of it to be. So the goal is going to be to figure out how much of the first solution and how much of the second do we mix together to make what they want us to make. Okay, so our first equation, we'll set up an equation for the total amount. And then we'll set up an equation for the concentration. Okay, and I'll walk you guys through the first one. There's a shortcut if you want to do the substitution in your head. I think we're just going to set it up as two equations. You can get away with one if you do this step in your head, but let's not do that. All right, so here's our two solutions we're going to mix. Okay, one of them is a 10%, the other one's a 25. Okay, and I made it very, very simple. Just put exactly what you need to do. When they're done, they want you to have 15 liters, and they want it to be a 12% solution. So obviously, we're not going to mix equal amounts of each one. If you did a 50-50, the amount you'd have would be the average of 10 and 25. We're going to use more of solution A than solution B, because it's only going to be a 12% solution. Okay, before we can set up an equation, we've got to represent how much of solution A and how much of solution B we're going to use. What would be a good letter to represent solution A? You could use X. Yeah, that'd be fine. What else?
A.
Yeah, you might, if you use A, then you'll remember A was for solution A, B was for solution B. If you want to use X and Y, that's fine too. Just make sure we keep them straight. Okay, so let's let this be A, and we'll let that be B. All right, first equation. Amount 1 plus amount 2 equals the total. Okay, well, we're going to use A liters of the 10%. We're going to use B liters of the 25%. And what do they want the total to be when we're done? 15. Okay, there's one equation. First solution plus second solution equals the total. And now when we do the concentration, they gave it to us in a percent. We have to change it to a decimal. That's important. Right, so let's start with the concentration of solution A. John, what would the concentration of solution A be as a decimal?
It's going to be 0.01 going to 0.1.
0.1.
Yeah.
Yeah, 0.01 would be 1%. Yeah, this is 0.1. Okay, so fill that in for concentration. And we're going to multiply that by how much of that solution we use. Okay, Kyle, how much of that solution are we using?
10%.
But how much of the 10%?
50.
How many liters of it?
18.
Well, hold on, let's back up. So we're going to mix some amount that's unknown of the 10% with some amount that's unknown of the 25%. And once we mix them together, we're going to have a total of 15. But right now, we don't know how much of either one we're going to mix. So this is liters. So I'm going to mix A liters here, and that's also liters. So how much of the 10% solution are we mixing?
A.
Yeah, A liters. We don't know how much. Okay, plus now we need the concentration of solution B. Okay, well, what would that be?
0.25.
Good, 0.25. And how much of that one are you using?
B.
B. Okay, and now the last part is both numbers. I want to know what the final concentration is going to be and the total amount. Eric?
In that equation that you just did, using 10% of the A, it should be 20.
Oh yeah, did I say 0.1? I wrote 0.01, thank you. And now, what's my final concentration? Yep, Cheryl?
0.15.
Yeah. That's of the final amount, 15 liters.
Oh.
0.12. That's the final concentration, and that's the final amount. Okay, so this equation is always concentration times amount, plus concentration times amount, plus concentration times amount. And the top equation, it's just two letters, add them up, equals the total. All right, so now what we're going to do is solve this top equation for one of the letters and plug it into the bottom. Let's get A by itself. What's A equal to in that top equation? Whoopee?
Divide by B. Oh, negative B.
Yep, not divide by B. You want to subtract it. So what would A equal?
A equal 15 over B.
15
Over B. And negative B.
minus B. Yeah. Okay. So A equals 15 minus B. Okay. What do I do with that? Where do I put that now?
For A is in the problem, so 0.1 times 15 minus B.
Yeah. Okay. A is 15 minus B. You're going to change A in the bottom equation to 15 minus B. Okay. And then we'll solve it. Okay, so after this, we'll need our calculator. Okay, so 0.1 times A, which is now 15 minus B, plus 0.25B equals, now the other side is just a number. So we should do that out. 0.12 times 15. Okay, 1.8. Okay, we did an equation like this earlier that had two distributives. This one just has one. So 0.1 times 15 gives me 1.5 minus 0.1b plus 0.25b equals 1.8. Okay, Cameron, what do I do next on the left-hand side? Yeah, combine those like terms. So you get negative 0.1 plus 0.25. What's that going to give me? 0.15b, yeah. Okay, and Amanda, my second to last step.
Move 1.5 over to the other side.
Yep, move that to the other side. And can you tell me what 1.8 minus 1.5 is going to be? It's going to 0.3, that was correct.
Yeah, sorry.
Now we're at our last step.
Wouldn't it be 0.15?
Point, let's see, right here, 0.15?
All right, I see.
Sorry, yep, it's 0.15. Yep,
Where'd you get 1.8?
Yeah, shouldn't be
1.8. Let me double check it. I did 0.12 times 15. Yeah, it should be 1.8.
Why did you
That's the concentration, 12%, right?
Yeah.
And that's the amount, 15. So it's always concentration times amount, concentration times amount, concentration times amount. Let me make sure I wrote it that way. Yeah. Yeah. So this is your final concentration, and this is your final total, the final amount. All right, and what's my last step? Get B by, divide by 0.15. Yeah, so B is 2. 2 liters. So, I think we had a spot. Let's just write it up here. Okay, so if I use 2 liters of solution B,
You go back down.
how much of solution A do I need?
Well, we don't have
We should know now. Yep. Because we know the total. Should be 13. Yep. Because it said that we were going to mix a total to get 15. So if you use 2 of one, use 13 of the other. Every mixture problem is exactly the same. Always put 2 letters added together equals the total amount, and then concentration amount, concentration amount, concentration amount. Okay, so you'll have one in the homework, same thing, it's just different numbers. Let's set it up just like that. Okay, question on that one? All right, so that's about as complicated as we're going to get for linear equations. All right, quadratics. Okay, so we'll finish up with this. What does a quadratic look like when you draw it? What's the shape of that? Yeah, it's like a U shape. Anybody remember what it's called? Parabola. Yep. Okay, so quadratic equations can look something like this. ax squared plus bx plus c. And you could get it equal to 0, so you could have like 3x squared minus 5x plus 6. Okay, that's an example. A, B, and C can be any real number that you want, except I'm saying A can't be 0. What would happen if A was 0? Yeah, all you'd have is this. Bx plus c. And if you graph that, that's not a parabola. What would that be? That's a straight line. It's like bx plus c. That's a linear equation. All right, so we don't want A to be 0. That would wipe out the quadratic part of it. Okay, one way to solve a quadratic equation is to factor it. Okay, factoring is great if the numbers work out nicely, and it's probably the fastest way. So let's just try factoring the problem. Okay, in this problem, I already did it, but anytime you want to factor, you always want to get it equal to what number? 0. So if this was the original problem, say you had that, first thing I'd want to do is minus 3, minus 3. Get the 3 on the other side, get it equal to 0. Okay, and when we factor it, how many sets of parentheses do you need? 2 sets, yep. Okay, now your first terms, you got to pick 2 things that would multiply together to give you 2x squared. So 2x and x. Okay, the next thing, you look at your signs. Okay. Positive middle, negative constant. So what do my signs have to be? Yep, one of each. Does it make a difference where you put them? Yeah, in this problem it does, because one's a 2x and one's an x. If they were x and x, then it wouldn't matter. So let's just try it like this. If minus plus doesn't work, we'll do plus minus. Okay, and 2 numbers that multiply to give me 3. 1 and 3. If 1 and 3 doesn't work, I'll try 3 and 1. Okay, so this is where factoring, you get a little bit of trial and error. Especially if this last number was like a 12. You got a bunch of ways you can get 12. 6 times 2, 3 times 4, 1 times 12. So you might have to try a few things. But this one I made pretty simple. Okay, there's only one thing you multiply to get 3. Let's check it. Does that work? Yeah. 2x squared. That's 6x minus x. That's 5x. Good. All right, now, because we factored it, it makes it very easy to solve. This times that gives me 0. What's the only way you can multiply two things together and get 0? If one of them or both of them are 0. So either the first one has to equal 0, or the second one has to equal 0. Or they could both equal 0. Okay, what value of x would make this first factor 0? Yep, 1/2. And what value of x would make the second one 0? -3. So if you plug either one of those numbers in, like try -3. -3 plus 3 is 0. 0 times anything is 0. Gives me 0. All right, same thing with a half. Half of 2 is 1. 1 take away 1 is 0. 0 times anything is 0. Okay, and the parabola, it's kind of similar to absolute value with how many solutions you can have. You can have 2, okay, like we do in this case. You can have 1, where it just kind of comes down and just touches it and goes back up. Or you could have no solutions. And you could flip those over as well. All right, if factoring doesn't work, that's where we can use our quadratic formula. Okay, quadratic formula, it takes a little bit longer usually than factoring, but it'll work on any problem. You can even use quadratic formula on a problem you could factor. It's just not the most efficient way to do it. Okay, anybody remember the quadratic formula? Yeah?
X equals -b plus or minus the square root of b squared minus 4ac all over 2a.
Perfect. Yep. That's your quadratic formula. Okay, so -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, this part under the square root has a special name. Just the b squared minus 4ac. Let's call it the discriminant. And what's nice about the discriminant is it very quickly can tell you how many answers your problem is going to have. It won't tell you what the answers are, but it'll tell you how many. So I could look at this problem, and in my head, if I can do b squared minus 4 times a times c, it'll tell me 2, 1, or no solutions. So I'll show you how that works in a little bit. Okay, to use the quadratic formula, just like factoring, make sure you get it equal to 0. Okay, got to have everything on one side and 0 on the other. All right, so let's try this one. Is this one ready to go to plug into quadratic formula? What do you think? Yep.
Move over to 1.
Yeah, we got to move the 1 over. Okay, so first thing I'll do, I'll write it as 2x squared plus 2x. And Taryn, how do we get that 1 on the other side? Yeah, we'll subtract. Okay, now we're ready. All right, sometimes what I do before I even plug in, just make sure I can figure out what A, B, and C are. Matt, what's A here? 2. Okay, and Brendan, how about B? No, there's no negative for B here. What symbol is in front of B? Just read that first. Read these first two terms to me. 2x,
Square
yeah, and now read this,
plus x.
plus. Yeah, so b should be a what? Positive or negative? Yeah, positive 2. Okay, and c is negative 1. Okay, we'll fill it in, see what we get. As we always do, if you get a square root, you can reduce. Okay, make sure you do that. And that's pretty much it. So we got negative b plus or minus the square root of b squared minus 4ac. Anybody notices a mistake, just let me know. All over 2a. All right, first thing I'm going to look at is the discriminant. I have minus, minus. Okay, Emily, what happens there when you subtract a negative? Yep, so that's going to become positive. Now I've got 4 times 2 is 8. 8 times 1 is 8. 8 plus 4, 12. All right. Only thing I got to look at there is the square root of 12. Is there anything I can do?
Oh, you can be.
Yeah, I can break that down. How does the square root of 12 break down? Yep.
8 times 4 and 3.
Yep, 4 and 3. So you could write it as square root 4 times square root 3, or 2 square root 3. And now what number can I divide out from every number on the outside of the root? A 2. 1, 1, 2. Okay, so now let's write our final answer. Negative 1 plus or minus square root of 3 over 2. Now you can also do this on the calculator. The only problem is it's going to give you a decimal. It's not going to give you this for the answer. So if you wanted to double check your answer, you could type this in, negative 1 plus square root 3 over 2, get the decimal, graph it, see if they match. Okay, but I need you to know how to find it this way, the exact answer, not just the decimal. Okay. Any question on quadratic formula? All right. And this will be our last one. All right, so this one says we basically got a rectangular piece of cardboard. Okay, and what we're going to do is we're going to cut squares out of each corner so we can take the sides, fold them up, and make like a little tray out of it. Okay. Does everyone see what I mean? Folding in on those dotted lines. So you're just going to fold those sides up and have a little tray with 4 sides. Okay, the size of the corner, or the size of the square we're going to cut out of each corner, it's 5 by 5. So we're going to cut out a square that's 5 by 5 from each corner. Right, so I just said that. We're going to fold along the dotted line to make a box. And the other thing I need to tell you to be able to solve it is how much stuff can this box hold? Well, it can hold 2,040 cubic inches. That's the volume of it. Okay, what I want to do is find the dimensions of the original piece of cardboard. How big, what's the length, what's the width? All right. Well, first thing I need to remember the formula for working with the volume of a rectangular prism. Because that's basically what this is, rectangular prism. Does anybody remember what that formula is? Like if you wanted to find the volume, think of a box. Multiply three things together. Yeah? Yeah, length times width times height. If you had to work with a shape that's any more complicated, I'll give you the formula. But for like a square or a box, you'd have to know that. Length times width times height. All right. Any questions so far? All right. Next thing, okay, it says here the length is twice the width. So the length is twice the width. Okay, let's keep that in mind. Let's look at that diagram. What's the length of the box in that diagram?
Twice the width. So these,
How would you write it in terms of the numbers we have here? What is my length? Let me write it out so we can see it like this.
Length is 2 times the width.
Okay, the length of, let's see, the length of the original piece of cardboard is 2 times the width. Well, let's find the length of my box after I fold it up. Maybe that was a little confusing. What would the length of the box be? Basically, that dotted line. Tyler?
Is it 2 times the height plus 2 times the width?
Well,
Because, like, does it give you the height?
yep, we do have the height of the box. Once we take that side and fold it up, we know the height of the box is going to be 5. But I need the length of that red line. So think about what it was originally, and then we're chopping off a little bit from each end. Eric?
Length of the box equals 2 times the width minus 10.
2 times.
The tabs are 5 and 5, right?
Yes, I like the minus 10 part. That's definitely good. And what did you say? The length, somebody said that earlier, length is 2 times the width?
That's what I was saying.
Yep, so you said 2w minus 10?
Yeah.
Perfect. Yep. That's exactly what you want. Okay, the length of the box. Well, the length is twice the width. Okay, that's that fact right there. Length is twice the width. Now, why did you subtract 10? That's right. But
Because of the tabs.
yep,
If you look at the tabs.
you basically are going to cut 5 inches off the left, 5 inches off the right to make that square. Okay, so there's the length of your box. And how about the width of your box? It's almost the same idea.
Allowed.
What is it?
Allowed.
Remember, length is twice, so we're going to use width. We're going to use the W. Because that's what they said to use. Length is twice the width. Yeah, Eric?
Half the length minus 10.
And how would you write that in terms of W?
So W width of the box equals 0.5 length minus 10.
0.5 length, or what if I just wanted to use the W instead? Let's use the same letter that we used here. Yeah, it would just be W. Okay, the only reason I don't want to use 0.5L, which is correct, is because then I'm going to have 2 different letters, and it's going to make it hard to solve.
Okay.
All right? So we started with this fact. L equals 2W. Found the length of the box. The length is 2W minus 5 minus 5. Right? The width. Here's your width. Okay, the width of the box after we fold it, it's going to be the original width minus 5 minus 5. Okay, and what about we'll just squeeze in height of box. What's going to be the height of my box when I fold the sides up? Yeah, it's going to just be 5. That corner that you cut out when you fold this side up, this side right here is going to become the height. Right, so now just fill in those 3 things into our formula for volume. Okay, So we've got the length of the box. We've got the width of the box. And the height of the box. And what do we already know the volume is going to be when we multiply that out? 2040. Right. What I'm going to do to plug this in, I'm going to distribute it out. So that I can plug it in, I'll use the calculator to solve it. Okay, so you get 2040 equals, that's 2w squared. Let's see, minus 20w minus 10w. And negative 10 times negative 10 is 100. All right, so we get 2040 equals, combine your like terms. 2w squared. What's negative 20 minus 10? Yep, negative 30. And you know what I could do? Instead of distributing this 5 out, divide it, yeah. Just take and divide each side by 5. That's going to make all the numbers smaller. 408. Okay, so we get 408 equals 2w squared minus 30w plus 100. Actually, somebody see something else I could divide everything by again? Yeah, you can make the numbers even a little smaller. If you're just going to plug it in, I'm not sure if it's worth doing that. So the calculator is going to give you the same answer either way. All right, so we get 204 equals w squared minus 15w plus 50. And my last step, if I'm going to graph it, I want it equal to what number? 0. So we'll bring 204 to the other side.
If we did it the way Eric said, we wouldn't have had to take out the 2, right?
Yeah, it might have been a little bit different, yeah. Yeah. So let's bring that over and then just graph it and see what we get. Okay, we get 50 minus 204. Now remember, this is a parabola, so it could cross twice. Probably it's going to cross in the negative part and the positive part. But negative values for length wouldn't make sense. Okay, so hopefully we get at least one positive value. So x squared minus 15x minus 150.
146, not 154.
Let me double check. So I just did this. Let me just double check. I did 50 minus 204. I think that's right. Yeah. All right, so we're getting one answer I can see on the negative part. It's probably another answer further to the right. If not, we have a problem. Let's keep going to the right. There it is. Okay. So at first you might think, whoops, maybe we did something wrong. You just have to keep zooming out until we find it. So we're trying to find where this equals 0. Which option do I use?
0.
Yeah. Okay. Go over towards that root. Okay, looks like it's over at about 21, 22, somewhere around there. So pick a point to the left. Pick a point to the right and do your guess. Okay, so we get our width is 22. Well, if our width is going to be 22 and the length is twice the width,
44.
my length is 44. And that, I think, was in inches. So that's the size of the original piece of cardboard before you fold it up. That's a tricky problem. That's not an easy problem to do.
How did you figure out the
22?
Yeah.
I did it on the calculator. I just calculated the root.
How could you do it without the calculator?
How could you do it? A is 1, B is negative 15, C is negative 154, quadratic formula. Since we already did it once, I'm going to hold off on doing that again. But I can write it. You could use quadratic formula. Okay, if you don't want to graph it, you could do it that way, but this way is a little faster. Okay, any other questions on that? Yep.
So are the 22 and the 44 the zeros on the graph where it intersects the x?
Well, the negative, no, the 44 is not. The 22 is. That negative, this one, don't even look over here. This doesn't even make sense. It's a solution to the problem, but it wouldn't work in real life because you can't have negative width. So, yeah, so really just look from 0 on to positives. Okay. Any other questions? All right, so we got about 10 minutes left. I think that's good. We'll stop with that. Okay, so the homework, page 89, there's not really that much. It's that quick section we did, 35 to 39. And then page 96, okay, that's what we spent most of our time on. Okay, that says 1 through 4, 9, 11, 13, 19, 25, 26, 37, 38, 52 to 54, and 58. Right, so we'll take a look at that tomorrow at the beginning of class.